Hello and welcome to AI4. Our next session is going to be led by Salam Baniahmed. He is the lead engineer of power systems and cybersecurity at Eaton. Please join me in welcoming Salam to the virtual stage. All right, it's all yours.
Thank you, Patricia. Hello, everyone, and thanks for being here today to join me in this great event, AR4. I'm really glad to be here, and I'm really going to be enjoying delivering the message that I'm bringing here in the cybersecurity session. Although the slide might say cyber resiliency, but I'm going to show you how cyber resiliency with a little bit of intelligence can act like a line of defense for operational technology systems against potential cyber attacks. Jumping into the first slide, let me start with what do we know? This is a little bit out of dated. It's from sometime last year. KPGM published a new CEO Outlook report. They made some kind of a interview with multiple utility CEOs about their cybersecurity concerns and cybersecurity posture for their infrastructure. And surprisingly, only $8 billion were spent on cybersecurity for utility infrastructure. I gave utility as an example of critical infrastructure because as Eaton, we believe that power is everything. Everything you touch, everything you see needs power, and the power is right there in your outlet, but there's a long story where that power is coming from. So thinking about $8 billion spent on cybersecurity might be a little bit surprising when you know that only 48% of these utility CEOs still showing concern that they will be becoming a victim of a cyber attack. And it's a matter of when, not a matter of if. This story has been going on for a couple of years now, and if history tells us something, it tells us that you might be secure, but you will never safe, because cybersecurity is not something that you achieve and that's it. It's a daily operation. It's everyday job, day-to-day job, and you need a lot of follow-up on everything that you do in order to maintain your cybersecurity posture. Although we do have all of this, we can see that 90% of the surveyed utilities around all of the globe, actually they experienced at least one damaging cyber attack. And when we say damaging cyber attack, we're thinking about the equipment that we have, which would create a lot of concern because, okay, if someone can live a little bit in the dark, that's okay, but damaging equipment will take a lot of time to recover from. 50% of these OT organizations have experienced at least one attack against their OT infrastructure, and that resulted with downtime for the past 24 hours. And here we're talking around 2017 and 2018. Thinking about all of this, we're looking into 429, and that's last year. And this number has definitely increased since last year. So we have 429 significant cyber incidents since 2006, which is considered a little bit concerning because the attempts are not considered attacks. And I've heard from some utility folks that they have tens of attempts every day, and sometimes it can reach hundreds. So based on everybody's thought and this quote that I like from Maitri, it says that no matter how strong your patching, compliance, and security software, a determined cyber adversary can typically find a way into your network, which is absolutely right. Most of the attacks that took place in the recent history tells us that there is an attack, and at the same time, we have a strong cybersecurity posture that we spent millions and millions on, and yet we're still getting attacked. It's a little bit different for cyber physical systems because we have to be concerned about the cyber side and the physical side, and going with the grid modernization initiatives that we have all over the place. The more digitalization or digitization that we go through, the less the security that we're getting, because now we're opening more attack doors to the adversaries to get in from. And if we're not really careful of what we're trying to do, it's going to cause a lot of problems on the long term and the short term, actually. So let's review a little bit what could be an impact of a cyber attack on an OT system. First, we're looking at impacting a loss of availability on the OT network. Now, thinking about the application and how critical the application might be, we don't know, no one knows until way later into the end of the story, what was the initial intent of the adversary? What do they want from the system? Do they want it to bring it down? Is the criticality coming from the power infrastructure itself, or from the loads that the power infrastructure is actually supporting? So the loss of availability can be a little bit of a concern, because once we lose the system, we lose everything that's being powered by it. Looking into partial loss of view for human operators. Sometimes we may have an attack, but the attack is going to be up in the cyber tree. The first step of the attack might be just losing visibility from the operator side, so the operator will not know what to do, and wouldn't even know if there's an attack or not. So I'm going to show an example later. How is that going to happen, and how can we mitigate this once we have cyber resiliency, an intelligent cyber resiliency line of defense that plays a role here. Now we can lose productivity and, of course, revenue. And most of the utilities and critical system owners are always trying to mitigate the risk, or at least migrate the risk to insurance companies. And insurance companies, of course, they will charge higher premiums if you don't have a solid cybersecurity solution or posture for your utility or for your infrastructure that will make sure that the impact is less, and the danger of them paying forward your losses are at minimum. So this would be a great drive for having cyber resiliency, because mitigating the impact might prevent or even minimize the loss of revenue that we might have. Of course, the adversary manipulation of controls, this is how they can damage equipment. And if they know what they're doing, they might disrupt the physical process, and of course start sending commands and controls that will harm the system, harm the equipment, and eventually shut down the system. And of course, if the control commands are beyond the designated design boundaries, this can cause a problem, and unfortunately, it may cause some loss of human lives. So it's really important, since we're dealing with OT systems, not IT systems. With OT systems, lives might be at risk. So cyber resiliency might be a lifesaver when it comes to a second line of defense. What is cyber resiliency to us? Simply, it's the ability to withstand and recover from a successful cyber attack attacks that are intended to disrupt power systems operation. So we have to be careful here. The attack is assumed that it's already taking place. Now, what's important to do right now is how the physical system will respond to it, regardless if the attack started from the IT side or started from the OT side, or if the adversary is actually taken over the IT organization or maybe the SCADA system. But the danger is really is facing the OT system that's underlying that IT layer, or let's say cyber layer. So what we need to do is to withstand and recover from this successful cyber attack. And hopefully the recovery would be at 100%, but worst case scenario, we need to maintain availability, at least for the critical loads or for the critical infrastructure that we categorize as critical as comparison to the rest of the system. Well, the way I see it, there's a path to regulation. Right now, cybersecurity is being regulated to some extent for transmission level when it comes to power systems. There has been recent talks that is going to be regulated at the distribution level. Most recently, there has been an alert from NSA and CISA. This alert actually recommends an immediate action. That the utility or the critical infrastructure, they need to have immediate action to reduce exposure across operational technologies and control systems. What do we mean by that? Reduce exposure, because if we have an exposure, if we have a system with high exposure to the outside world, it's more susceptible to get attacked. And the importance of reducing the exposure comes from the cyber resiliency concept that we need to be able to withstand. So the reduced exposure can happen at the design stage, where we're making sure that we considered all the cybersecurity aspects starting from the IT organizational IT and end-to-end communications. But at the same time, if the worst happens, or when the worst happens, we need to make sure that we can even reduce the exposure even more, so we can at least maintain availability for the rest of the system. NIST last year, specifically November last year, they published what you can call a guideline for developing cyber resilient systems. I recommend looking at that. It's a great source, and I like the terminologies that you use. And I'm hoping that this terminology will be a great, I don't want to say replacement for cybersecurity terminology, because cybersecurity is still essential for us, but at least for people who wants to get into the cyber resiliency field, this would be a great start for them. Every couple of years, NERC provides this kind of exercise. It's called GRID exercise for utilities and their partners, where they can actually provide their in a way they can practice or show their resiliency practice on how they're going to respond to a cyber attack. What's remarkable from this report that came up, I think March this year, one of the recommendations that came out of this, telling the utility people, hey, go talk to your vendors, because obviously we need to start thinking about securing the OT environment as well as the IT environment. And in order to do that, you definitely have to talk to your vendors and making sure that their products are up to date, and there's a cybersecurity product cycle for development is being used. And at the same time, you need to make sure that if you have certain requirements for cyber resiliency functions, these products can actually provide that, or maybe they can be redesigned or designed to provide this kind of functionality. So let me give a quick example of why do we need cyber resiliency. Assuming that the current practice that we have for an emergency response against a cyber attack, we have a power system, let's say a substation with a couple of feeders, there's a microgrid and a branch, whatever that is, and we have data centers, building management system. Everything you see here might be considered critical depending on the application, but most likely it is critical. So if there's a cyber attack at some time, what might happen at the beginning, if the attacker knows what they're doing, the first thing that would happen that you're going to lose your power system. Is going to be shut down, regardless if this shutdown is happening by the operator or happening by the cyber response team. Whoever is going to respond immediately, the first time, just to be safe, they usually shut it down. Now, the operator might lose visibility, and this is one of the impacts that we talked about. So what the operator would do, it would contact the cyber response team. The cyber response team will take a look at the playbook, or maybe they memorized it. The playbook will tell them, hey, just fetch people and send them, dispatch them to the field, try to bring back the system partially or whatever, and they have to keep in communications so they can make it sure that they re-energize the system safely without risking anybody's life. At the same time, they will start fetching IT people, and let him know, ask him to try to figure out what's going on, help the operation guys to bring back the system, and of course looking into the intelligent electronic devices in the field and help them bring it back side by side with the physical system, which might take a lot of time, and that's where depending on depending on how severe or the severity of the situation there, federal government would need some answers of what happened, since it's considered a critical infrastructure. And of course, there will be investigators hired by the utility or hired by the government or already part of the government. Then will be some kind of legal ramifications for this if the shutdown or if the blackout is going to take a lot of time. So it's going to be costly. Then the organization or the executive level is going to be responding to the federal government. And if we have no information from the cyber response team immediately, the executive side is not going to be providing any questions, which is a real pain. So thinking about why do we need to live in darkness while we can have a second line of defense? In order to do that, we need to figure out how can the intelligence be embedded into my system, and where is it going to be embedded. Looking at the diagram here, we can see the IT cybersecurity or the cyber layer is literally covering the operational technology. Yes, recently a lot of people are trying to add more cybersecurity considerations at the OT side, but we have to be careful because we have data is different. The data traffic is different. What the packages are actually carrying is different, and most of the cybersecurity solutions that's being provided by the IT vendors are actually suited for IT traffic, which is a little bit different. And thinking about when it comes to OT technologies, since the traffic is different, we have to have different considerations on how to deal with it, how to look at the impacts of adding more security, especially when it comes to cryptography and adding more delays or jitter to the traffic, making sure that everything can happen. It has to be reported upstream. And of course, this will might impact the network and create some kind of contingency problem. And of course, might even without a security or a security concern or an attack, it might shut down the system. So as I mentioned, the critical infrastructure on a daily basis, it faces a lot of attempts. Not all of them are reported and even not all of them are actually detected, because it might be a simple testing the water. Somebody's trying to get in or do something there, which is really annoying, especially if you don't know that's there. And what's even more annoying, if you know it's there, there's nothing to do about it because you don't have enough information. So thinking about what we can, it's looking at the OT infrastructure as its own world, meaning that the approach for cyber resiliency is a little bit different from cyber security. Cyber security starts from the outside and goes into the inside, starting from the cyber side and it ends at the OT side. And most of the times, unfortunately, and this is a common practice, it really ends at the edge of the OT system. Usually they have a system where the firewall that sits between the OT and the IT that prevents certain traffic and everything, but sometimes the attacks actually starts from the OT system, which is really annoying to think about, because there's unlimited cyber attacks or cyber paths for the attacker to get into the OT system. So the bottom-up approach that needs to be thought about, it's pushing everything at the edge. Now, the edge level intelligence can help mitigate the physical and economical impact. So how is that being done? It's all about adding more intelligence to what's called the intelligent electronic devices that's already in the field, because they have the capability to communicate and can hold general awareness to its own environment, especially to the neighbors and geographical location and the logic location within the cyber tree or the OT system tree. So system level automated response can be added to that with the general awareness of the neighborhood and what's happening there. We can come up with a plan, and that plan will help these devices to come up with a decision on how to act when a cyber attack actually takes place. This will help us create a defense line, and this line can make the OT system push back against a cyber attack, or at least contain the cyber attack or the attacker within a small area of that system, while the rest of the system actually maintain its availability, and of course until the response team can be there. How can this help? Now the operator is looking into the system, everything is okay. There is an attack. And now the first thing that I need to think about when it comes to an attack, I don't have to trust the backbone. If I have intelligent devices in the field, these devices should not trust anyone else. If you can maintain your system by itself, it should contain itself and of course isolate itself from the rest of the environment. Now the cyber team, when they get fetched, actually it will help them dispatch less people to the field, and of course the operational center would be maintaining or may lose visibility, but at least I know the system is running and it's running within its limits. So the investigators might be able to fetch data faster because these devices are isolated, but they still can see what's happening around them. And of course, at the end, we can come up with a report to the executive level so they can respond to the federal government. Now, I really appreciate you listening to this today. This is really important because cyber resiliency is going to be the next thing, right side by side with the cybersecurity, and thinking about this second defense line of defense for your critical infrastructure will help a lot. I provided a high-level approach, a lot to think when it comes to the intelligence and how we can add to the IED devices there, considering their capabilities, considering their application. But at the end, what we need to achieve is a really solid second line of defense after cybersecurity that works side by side and makes our life simpler. Even when there is an attack that's actually took place, we should be able to know what happened and how to respond to that automatically or even within a timely manner, so we can minimize the time where the attacker can actually play with the system or try to manipulate the system in a harmful way. I thank you again, and thank you so much for listening. If you have any questions, if you want to do offline, please, here's my contacts. Please reach out, and I would like to have a talk about the same topic. And if you have any questions now, I'm really glad to answer. Thank you very much.
Thank you so much, Salam. A big virtual round of applause for you. That was awesome.
Thank you.
So if you are looking for your next session, you can go ahead and check out the program page or do some virtual networking on the platform. All right, we'll see you around, and thank you again.
Thank you.